So today we are going to take a look at the unit circle. So we're going to look at how it's developed and how do you find the exact values of different trig functions. So a unit circle is just a circle that's on the coordinate plane with a center at the origin and a radius of 1. So no matter where I go, this radius is going to be 1. So we can find all of our trig functions and develop the unit circle based on a 30, 60, 90 triangle. So I can drop down this side here, if this is 30 degrees, and make a right triangle. If this is 1, okay, that's the hypotenuse, and we know that the side opposite the 30-degree angle is half that, so that's 1/2. Okay. And then the side opposite the 60-degree angle is 1/2 times √3, so √3/2. So remember, our cosine is the adjacent over the hypotenuse, so this would be √3/2, and our sine is opposite over hypotenuse, which would be 1/2. The tangent is opposite over adjacent, so 1/2 over √3 halves. And with complex fraction, we're going to flip it and multiply. So 1/2 times 2√3. Okay, and these cancel, and you get 1 over √3, and you got to rationalize, so √3/3. So you get √3/3 for the tangent. That's not right. Okay. Now all of these other angles are reference angles. So if I come over here, this 150 goes from here to here, but it has a reference angle of 30 degrees. So that means that things are almost the same. Using the 30, 60, 90 triangles, I've got this as -3√2, but since it's in this quadrant, all of my x values are negative. So it's -3√2, and then this would be +1/2. So -3√2, +1/2, and then this would be a negative divided by a positive, so -√3/3. And you would continue to fill this out, and I would like you to do that. Now, one thing I want you to notice is that with this point right here, I'm going to erase this, okay? The coordinates of this point are -3/2 and 1/2. Okay? So your cosine is always your x, and your sine is always your y. So take a second and fill out these last 2 rows, and then you can pause. Here are your values for cosine, sine, and tangent. Now for a 45, 45 degree, 90-degree triangle, we're going to do the same thing. If this is 1 and this is 45, 45, remember that the legs are the relationship for the 45, 45, 90 triangle is 1, 1, √2. So in order to find this side, you've got to divide 1 by the square root of 2. Okay. And if I rationalize that, it becomes √2/2. So both of my legs are √2/2. So in this case, both sine and cosine in the first quadrant at 45 degrees is root 2 over 2. Now the tangent, again, is your, basically, your y over x, because it's opposite over adjacent. So tangent is y over x, or in this case, 1. I'm just going to go over here because we did the other. Okay. This angle here is 225. Okay. Its reference angle is that 45. So this is root 2 over 2, negative, and this is negative root 2 over 2. So both your x and y's are negative here. But that would make your tangent a positive 1. Okay. Go ahead and take a second and thinking about the signs in each quadrant and where your reference angle is, fill out this table. And then you can pause and double check your work. And lastly, well, kind of lastly, we have the 30, 60, 90 triangle again, but this time this is my 60 degrees. My hypotenuse is still 1. My short side is 1/2, and this is root 3 over 2. Okay. Using that relationship with our 30, 60, and 90. So 1, 2, root 3 that you learned in geometry and that we reviewed. So your cosine is the x, 1/2. Your sine is the y, root 3 over 2. And your tangent is y over x, so root 3 over 2 divided by 1/2. And then when you flip that and multiply, you're just going to get root 3. Okay. Go ahead following the pattern and fill in those next. And then you can pause again and what I want you to notice, look back at your notes, the signs for each quadrant. Oops, I don't want you to notice the signs in each quadrant for this. Sorry, what I want you to do is let's talk about the others. I've got 0 degrees, 90 degrees, 180, and 270. Okay. So, or 0, pi over 2, pi, 3 pi over 2. Okay. So in my unit circle, if this is 1, okay, then my ordered pair is 1, 0. So if my cosine is x, it's 1. My sine is 0. Tangent is sine over cosine, or 0. Up here, my point is 0, 1. So my cosine is 0. My sine is 1, but my tangent, because you can't divide by 0, is undefined. Over here, this point at 180 degrees, or pi, it's negative 1 and 0. And so there are my values. Okay. And then down here, it's 0, negative 1. So cosine is 0, sine is negative 1, and tangent is undefined. All right. Now I want you to notice the signs in each quadrant, okay? In the first quadrant, when you looked at everything, everything was positive. So all of your signs are positive here. Okay. Here, if you look back, only your sign was positive and these were negatives. So our sine was the only thing positive here. In this third quadrant, our cosine, our tangent was the only thing that was positive. And lastly, in the fourth quadrant, our cosine was the only thing that was positive. So you can check it using the, the values of x and y. Are they positive or are they negative? Or there's this little catchphrase that says all students take calculus. And this tells you all students take calculus, what's positive and what's negative in each thing. All right, so let's find the exact value of the trig functions. And what I'm going to do is I'm going to use the reference angles. I know that my reference angle here is 60 degrees, and we're asking for the cosecant. So my my sine goes with cosecant. So sine of 60 is root 3 over 2. So my cosecant is the inverse of that. And it is 2 root over root 3 then. And then I've got to rationalize the denominator. So I get 2 root 3 over 3. And this is in the fourth quadrant where sine is negative. So it's negative 2 root 3 over 3. Cotangent, all the way around here, if this is negative 120, this is 90, this will be 30 degrees there. So my reference angle here is going to be 60 degrees again. Okay. So for cotangent at 60 degrees, the cotangent, or the tangent at 60 degrees is root 3. Okay. But the cotangent is the inverse of that, so 1 over root 3, and if I rationalize, it'll be root 3 over 3, and tangent is positive in this quadrant, so is the cotangent. Okay. Going to go with that cotangent again. So 45 degrees. Okay. Here we know that both the sine and the cosine are root 2 over 2, which makes the tangent at theta equal to 1. And if I do the inverse of that, that's the cotangent, would also be 1. Okay. I don't know why I keep picking 60s, but here, this is 240, so 180 minus 40 is 60. So it's cosecant, it goes with sine. The sine of 60 is root 3 over 2. And since it's cosecant, we're going to flip it. And we're going to rationalize the denominator by multiplying by the square root of 3. So 2 root 3 over 3. And sine is positive in this quadrant, so it's positive. So we looked at a whole bunch of things setting up the unit circle. You need to memorize the unit circle, or you need to be able to figure out quickly using reference angles how to find them using reference angles and special right triangles. So have a mathtastic day.